Hey everyone, it's Mr. Anderson here, and today we're going to move into Chapter 8 in our CPM Common Core Algebra text. We're going to start today with Section 8.1.1, and we're going to look at the relationship between the sum and the product in our area model, right? This is something we've already started, and we're going to continue to revisit it today. We're going to start with 8-1, and we're going to review an idea, and we're going to use that idea to advance. And I'm going to kind of go quick today, because there's several things that we've got to make it to, and I want to limit this video in length. So if you need to, pause the video, back the video up, do what you've got to do in order to make sure you're getting everything you need to be getting, okay? So I've got some notes already set up here, and the notes start with 8.1. And it says, let's review real quick what we know about sum and products. Write the area of the rectangle as a product and as a sum. Well, one of the things that I'll remind you of is each one of these tiles in our rectangle is named by its area, right? So this first tile is an XY tile. This tile is a Y tile. This tile is a X squared tile and an X tile, etc., etc. So I can go ahead and just label all these things real quick. And if I do that, it makes it easier. Okay, and these are all just unit tiles, okay? And then I just write all these things kind of combined, and order doesn't necessarily matter, although we do like to write these things with usually the highest degree first. So I might write the X squared first, and then I could write the XY, right? Addition's commutative, so you don't have to write these things in this order. And then I'm going to group all of my y's together. So the question is, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. And you know what? I might write the x's before that alphabetically. So I've got 2 of those x's, and then I've got 8 y's. And then, of course, 1, 2, 3, 4, 5, 6, 7, 8 unit tiles just makes 8. Okay? So there is the sum of my algebra tiles, but we can also write this thing as a product as well, and we do it with the dimensions of the tile. And so right down here, these are just 1 unit wide and 1 unit wide. This is X unit wide, and this is Y units wide. So right here, I've got Y plus X plus 1 and 1 make 2. So I can set this equal to that dimension, right? Because the dimension of a rectangle, the area of a rectangle is its length times its width. And I've got, or base times height, and that's the base. Y and X and 2 right there. And then I can find the other dimension right here as well. I can just go ahead and I can say, okay, this one right here is X, and then I've got 1, 1, 1, and 1. And I'm going to run out of room there, but you guys can clearly see that that is going to be X and 4. And I can write that as my other dimension. And I can remind myself and you all that I've got the base and height, and when I multiply them together, it is equal to the sum, right? So the product in this case of the dimensions is equal to the sum of all of those tiles, okay? The other thing that we're going to go ahead and do real quick, because it's going to advance our progress moving forward, is we're going to remind everyone what it's like to use a generic rectangle to actually do some multiplication and then write the solution as a sum. So I've got a product of 2 binomials here, 6x and 6x minus 1, and then 3x plus 2. And I'll go ahead and I'll just write this as a 2 by 2 generic rectangle. I've got 6x and negative 1 or minus 1, and then 3x and 2. And I'll just multiply these things together. 6x and 3x makes 18x. Don't forget the squared. Negative 1 and 3x makes negative 3x. 6x and 2 makes 12x. And then, of course, negative 1 and 2 makes negative 2. Now I'll go ahead and put these things together. Nothing goes with the 18x squared. It's just it's a unique term there. It doesn't have any other like terms. Nothing is going to go with the 2, but these 2 items are able to be grouped because they are like terms. We've got a 12x and we've got a negative 3, and we add those things up and get 9x. So right here, I've got the area as the product. Right here, I've got the area as a sum, and I can even do that without building those items in algebra tiles. Okay, we're going to go ahead and take this. We moved forward. Now we're going to kind of maybe move backwards, and we're going to change a sum to a product. And when we do that, it's called factoring. Okay, and we're going to run into a situation, and I'll just share with you guys outright on the video. the answer to this question. Not every expression is factorable, okay? And we're going to go ahead and do some investigations with the algebra tiles. And I've got one that I'm going to set up for you here. And in fact, I've already got it set up. We're going to factor 2x squared plus 7x plus 6. And algebra tiles are really, really helpful for this. And you guys, if you're using your CPM ebooks, can do this. It's so easy. You just click on the algebra tiles link, and I'll show you what I did here. I set myself up with the corner piece background, and then I just got all the tiles out. I've got 2x squareds out there. I've got 1, 2, 3, 4, 5, 6, 7 x's, and then I've got 1, 2, 3, 4, 5, 6 unit pieces. And you're always going to start with that squared term in the corner. And now I've got 2 of them, and it doesn't really matter where I put it, but my goal is to build a rectangle. And the next step is going to be, well, how in the heck do I go ahead and rearrange these guys to do that building, right? And you can kind of see that they lock into place there. I'm going to get this unit tile out of my way, and I'm going to intentionally build this one wrong here to see the error of our ways, right? I'm just lining this up because I've got every piece I add here gives me a rectangle so far. But look at this now. No matter what I do, I can't line these guys up to give me a rectangle. Notice what I got here. Like I've got, oops, I'm a little overlapping there, and there we go. Now look at, I've got a little lip there, and that's not a rectangle, and I can't put another piece on there in any way, shape, or form that gives me a rectangle. So I've got to consider a readjustment, and the way we want to do this is likely with a double click there and a rotation. Oops, obviously a single click will turn it negative. A rotation of those tiles. Now look at what I got. Okay, I've got 2 on the side here. I've got 5 across the bottom. Now that gives me 1, 2, 3, 4, 5 space. I got 6 of these tiles. Let's try something else. What if I do this? Do that, and I do that, and I think this one's going to work. Oh, all right. Okay, I can take this. I can drop that in there. Look at what's happening. Okay, just by goofing around with that just a little bit. I may not find it perfectly, but now I've got it, right? I can drop these in here and things are lining up perfectly. Look at the way that fits. Okay, now the question we've got to answer is, what are the dimensions of the rectangle that I just built? Look at this. This right here is an x squared tile, but how long is it across the bottom? It's x. How long is this one? It's x. And then this is 1 and 1 and 1 units long. So I've got x and x, 1, 1, 1. That's 2 x's and 3 1s. So I can go ahead and write that dimension. I'm just going to go back to my notes and do that real quick. I've got 2 x's and I've got 3 1s. Now, we know that we're writing this sum as an area. So check out what I did there. I grouped it as a binomial, okay? And then what do I got here? Right, I've got an x squared tile, so it's x units tall. And then this x tile is 1 unit tall and 1 unit tall. So I've got an x, and then I've got a 1, and I've got a 1. So that's x and 2. Okay? And so I can write that height as an area as well. Now look what we've done. We've written the sum of these parts as the product of these dimensions, right? That's called factoring, and that's what we're moving into. And it's really going to be a very, very helpful tool for solving quadratics. And you're going to see me do that with algebra tiles. You're going to see me do it without algebra tiles moving forward. And I can go ahead and do it if I've already got the sum broken up here, right? We've got a generic rectangle in 8-3 that's already kind of filled in, and our job is to go ahead and find some dimensions. And it says here, work with your team. We can't do that, we're on a video, to find the sum and the product for each of the following generic rectangles. Are there any special strategies? Well, let me show you how we might do this. The sum is actually really easy. Nothing is going to go with the 6x squared, but I will remind you that we do have a pair of like terms here. We've got 2x and 15x. That makes 17x. And then we've got a 5, right? There is the sum. That's really easy and really straightforward. The product is a little more difficult here, and I'll show you this part because it's kind of cool once we see it work together. I'm going to isolate this 5 first. I'm going to ask myself, how can I make 5 with multiplication? And there's only one way to do it. It's with a 1 and a 5. Okay? Now look at that, right? I'm saying then, what in the heck times 5 makes 2? Right? Like if I multiply 5 and another number, do I get a 2? Well, no. But that doesn't mean 5 and 1 aren't right. It just means maybe I got them in the wrong spot. Okay, now look. What in the heck times 1 makes 2? I'm sorry, 2x, my fault. And the answer is, you guys know, 2x, right? Because 1's our multiplicative identity. Anything times 1 is itself. Okay, so believe it or not, I've got that first dimension across the top really kind of filled out. And I'm going to ask the exact same question. 5 times what number is going to give me 15x? So I consider that. Well, it's got to have an x. 5 times what gives me 15? Hey, the answer is 3. 5 times 3x gives me 15x. And then I've got to check. I've got to check, and this will work every single time. 3x times 2x. Does that give me 6x squared? Well, 3 times 6 is 2. I'm sorry, 3 times 2 is 6. X times x is x squared. For sure, that gives me a 6x squared. So now let's go ahead and write this as the product of the dimensions. And I will put these as in as binomials. And I do have to group them this way for the purposes of multiplication. So I've got 2x and 5. And I've got 3x and 1. And that is going to work out for me there, right? With our FOIL pattern, if you will, or our distribution pattern. Okay? Check this out. One other problem here that I do want to get to before we talk about some review preview, and then if I got some time, I'm going to go back and tackle another factoring problem for you guys. All right. Well, working on a problem in 8-3, Casey noticed a pattern with the diagonals of each generic rectangle. However, before she shared her pattern with the rest of her team, she was called out of class. The drawing on her paper looked like the diagram below. Can you figure out what the diagonals have in common? And here's what I want to share, right? I've got a diagonal here, and I've got another diagonal right here, and ask yourself what those diagonals have in common. Okay, and the answer is, what happens when you take 2x and multiply it by 15x? And what happens when you take 6x squared and multiply it by 5, right? Consider that just for a minute. Okay? Did you figure it out yet? Bottom one might be easier. What's 6x squared times 5? Hey, that's 30x squared. What's 2x times 15x? Hey, that's 30x squared. Well, check that out. Those two things are the exact same. The product of each diagonal is going to be equal in this case. Let's bump back up here, and let's see if that works here as well, right? What's 2x times 15x? Okay. What's 6x squared times 5? 2x times 15x. Hey, that's 30x squared. What's 6x squared times 5? Some of you guys realize that's the exact same problem, right? What if we jump over here? What if we tackle this one? Okay. What's 2y times 15x? 2y times 15x is negative 30xy. What's negative 6 times 5xy? Also negative 30xy. All right, let's back up to one more. All right, let's just see, right? Let's just see if this works out. Let's back up to one more that we already did, right? If I decide I want to write this one real quick, A, we already did A, in a generic rectangle, okay? And we've got, oops, let me draw this real fast. We've got 2x and 3, and we've got x and 2, right? I want to know if I've got everything factored maybe correctly. This would be 2x squared. This would be 3x. This would be 4x, and this would be 6. Now here we go. Let's check these diagonals. All right? What's 3x times 4x? What's 2x squared times 6? Did you figure it out? They're both 12x squared. Okay? So that's something that if we're factoring using this generic rectangle, we should be able to see pretty quickly and pretty easily. All right, ladies and gentlemen, we are going to continue with factoring. This was a real scratch the surface introduction. Okay, we're going to move into factoring in some future lessons in 8.1.2 and 8.1.3, or I'm sorry, not move into, continue with factoring. We're going to start to see some special patterns emerge. And ladies and gentlemen, we do have a tiny bit of review preview for you today. All right, and that review preview is just number 6, 7, 8, and 9. So go ahead and try those things so you know what kind of questions you're going to have. Folks, thanks for watching. Have a great day.